DraftScience video. Yay. So Holiday has posted a Richard Feynman video. I don't know why. I mean, it's available online. I mean, you know, it's okay, I guess. Anyway, it's the Feynman video where he's doing the two-slit experiment. So we're at 28 minutes into the video, and this is where he makes a fundamental error. And I just would like Holiday and Pierrot and all these defenders to admit what Richard Feynman says here is inaccurate. It's not the truth. It's not reality. And yeah, I just like that admission. I don't know why Holiday posted this as if this is good science. It's inaccurate. It can't be good science. So isn't it the description of it? Are you illustrating bad science? What are you illustrating? What are you talking about? What are you doing? What's the message behind posting this video? It has a catastrophic, classic error. I mean, the error has been made more than once, but it's an error. Would you admit it's an error? So here we go, play it.
We say maybe it comes, we can analyze this by thinking that the electrons come through this hole or through the other. So we can close one hole and measure how many come through hole number one, and we get that curve. Or we can close this hole and measure how many come through hole number two.
Okay, so he couldn't be saying it more clearly. He's not conceding single slit diffraction. So he's saying with one of the slits covered, there's no diffraction, no funky signal. And we know as a fact that if you use monochromatic light, light of a single frequency or close to it, you will get a diffraction pattern with a single slit. Now the pattern will be 8 times smaller in terms of its amplitude, as I understand it. Its amplitude. But what I think is the more relevant point is that the central maxima will be 8 times this. First peak will be stronger in the single slit, and proportionally these will be 8 times weaker by comparison to that peak. But it's a clear diffraction pattern, and it's more visible with lasers now than it is with the usual setup. And so let's understand again that in Feynman's description of the experiment, he has the aperture that spreads the light before it gets to the two slits. We know the aperture is creating diffraction before the light is even getting to the slits. So let's concede this is the classic two-slit, and that the modern versions, you know, people aren't too clear sometimes whether they have the aperture. Some use lasers with the aperture, some do not. And this is a significant fact. But let's just admit for right here, this segment right here, this bit of description of what happens is inaccurate. There is single slit diffraction. There is not two curves like this. There's two curves like this. Two jiggly jaggly things will happen, but this will not happen. You will not just get a blob of light. You will get diffraction. And I'll just add this since we're here. I mean, I'm not going to play. Well, I'll play a little more to see where it goes. But I mean, I don't want to distract too much away from just getting the concession that what Feynman described here was wrong. Fundamentally is not a description of the actual factual circumstance. It's incorrect.
We get that curve, and these two added together is not this, and so this is not the same as N1 plus N2, and it does show interference. It shows interference, and in fact,
well, I mean, saying it shows interference when you're describing blocking one of the slits is again kind of, you know, so again, that's the context here. He just switched subjects in the middle of the video. So no point, I mean, he's not going to talk about the single slit any further. So I'll see what other errors are in here. But again, that's just a fundamental error. To say that there was no diffraction pattern for the single slits is in error. It's not correct. I really wanted to go, I guess I wanted the picture to do my final point. Again, what my argument is that what changes in the double slit versus the single slit experiment. So in the single slit, the strongest light is the furthest away from either one of the slits, right? The strongest light goes right through the middle where there's no slits, no material. And in the double slit, the strongest light goes right next to an impediment, right next to a surface. So the strongest light is more likely to be diffracted by any interference with surface forces. Let's call them surface fields. Clearly, you can just see that, right? Double slit, most intense light right by the finger. Single slit, most intense light, nothing near it. You can see that. And when there's an aperture creating the light, we know the light goes out in a cone, that it is much more intense in the center and less intense on the fringes. So obviously that would also help create this circumstance. So what I'm saying is the interference pattern. Let's see if we can get the drawing.
Mathematics is given by this one formula that the probability.
Okay, so we have this wavy thing. My argument is what's happening is in the two-slit experiment is the light furthest from the material, the light furthest from surfaces, goes straight through and creates the central maxima. The light that goes near the surfaces diffracts, and the closer it goes to the surface, the more it diffracts. So there's a lot of very intense light being highly diffracted in the two-slit experiment, where the weakest light is diffracted in the single slit. I think that can be understood. So Hoffladay, I mean, why do you post this video? What are you saying by posting it, mirroring it? And we can see that Feynman is fundamentally inaccurate in the premise to the argument he's making, that he describes reality inaccurately. You can see that.